Hey, how about that? Look, now we have audio. That was just so hilarious. Hi, let's start this over again. My receiver, my mic receiver, was not on for the wireless. Hey, welcome to the show. It's me, John Park. We're here for another episode of John Park's Workshop. This time with sound, even. So thank you for joining. I've got some fun projects I'm working on here in the workshop, some that I've just finished, some that I am just starting. Yeah, I was trying to point at that. Oh God, the camera's backwards. Right there, that's the Computer Perfection. I've just finished that project, and the Learn Guide should be up soon. It's probably no coincidence that Lars has a pair of scissors there. What the heck? Now audio. Thanks everyone for chiming in on that. I appreciate it. You'd think at this point, I've been doing this for what, I don't know, 4 years, 5 years, something like that, and yet still somehow, sometimes, I forget to turn on part of this audio setup. So what else? I've got a coupon code for you for today that you can use when you're buying some stuff in the Adafruit shop. I've got a JP's Product Pick of the Week wrap-up, recap. I've got a new Circuit Python parsec for you. And like I said, I'm kicking off some projects. So let's start off with that right there. That's your coupon code. So head on over to the Adafruit store, find some neat stuff that you want to buy, and get yourself a discount on it. No need to pay full price. You can get 10% off. So if you head to the Adafruit store, that's it right there. Just go to adafruit.com. You'll see we've got a couple of new products listed there. There's a little link for view all new products, and then some categories of some stuff you might want to look into. Go find some neat stuff, throw it in your cart. Anything you throw in there that isn't a gift certificate, software, or a subscription, but actual physical goods, stuff, things, those are going to be 10% off. You just throw that coupon code in the cart on the way out, and you'll get your discount. And by the way, that also is stackable with the freebies. So if you get enough stuff, you can see here, if I just go to adafruit.com/free, You will see we've got some freebies at the $99 order size. You'll get a free PermaProto half-size breadboard. At $149 or more, you get a KB2040. And at $200 or more, you get free UPS ground shipping in the continental United States. So head on over to Adafruit, buy some stuff, get yourself a 10% discount as well on the way out with that coupon code roulette, which I only just found out today means little wheel in French. How about that? Never thought about that word. Roule. I bet that's how they say it. Roulette. Anyone here speak French? Hopefully not. So let's see. Comments in the chat, by the way. Hello, and thank you for joining over in our YouTube chat as well as in the Discord. If you're somewhere else and you're wondering where to join up in this chat, it's probably over on the Discord. So you go to adafruit.it/discord. You'll see it right there. That's what it looks like. You can see I'm in the live broadcast chat channel right there. That's where this conversation is happening, but we've got a whole bunch of other stuff going on in other channels all the time. Something like, what, 30,000 or 35,000 members now in our Discord, so head on over there and join the conversation. And also thanks to people for hopping by over in the YouTube. Dave Odessa, I have not forgotten you. Yes, one day maybe we'll get 1080p. I'm nervous about that only because I had issues in the past. But yeah, 1080p would be great. Maybe I'll be brave enough to try it next week. We'll see. Maybe hold me to that. We'll see. At least we got audio, right? So what else did I say? I said, hey, I've got this show right here. That's the Product Pick of the Week show. That happens on Tuesdays at 4 o'clock Eastern Time. Do your time planet math to find out what time that is in other places. You can even ask over in the Discord. I think you can ask for the show times in different time zones. Not all of them, but some. Anyway, on that show, I like to pick some new product or some oldie but goodie and give you a little rundown, a little bit of a demo, and a deep, deep discount. This week we got 50% off on that one right there, the host, the USB host. So here's a little recap I got for you. It is the Feather RP2040 USB host. Rather than plugging in, let's say, your mouse or your keyboard straight into a computer, you can use a microcontroller, this one right here, to intercept that incoming USB and do stuff with it. We have one core of the two and both of the PIOs doing all of the USB host duties. That leaves the second core for everything else. Take mouse information and apply some logarithmic filtering to it so that it actually slows down the cursor movement when you move the mouse quickly. Mouse slowly left and right, it's moving at kind of what I would consider a sort of normal mouse pace. But now if I move the mouse quickly, it actually is slowing it down. It's actually making it a little bit more accurate, which could be really useful as an assistive technology device if you have a bumpy ride, you're on the train. It is the Feather RP2040 with USB host. It is the Feather RP2040. Yeah, sure, maybe that'll just keep looping over and over again. Sorry about that. Technical difficulties. They're the spice of life, actually, to paraphrase. So let's see, what else have we got? By the way, yeah, like I said, I'm excited about that Feather, and I'm hoping we can start to develop some cool stuff for MIDI with that, as well as other uses. It's Arduino only right now, but maybe we'll get development in CircuitPython for it. We'll see. That could be tricky, the kind of speeds required, but who knows. But exciting times, and I have one right here. I am a big fan of these feathers that scrunch everything up to one end so that we can fit a cool accessory on the end. What do we have so far? We've got the DVI feather. We've got the USB. Is that it right now? I think there's probably some others that Lady Ada has been working on. So how about this? Next up, I've got a cool little circuit Python parsec for you. So check this out. Circuit Python parsec. All right, so for the CircuitPython Parsec today, I wanted to show you how to do a really nice type of color blending with Neopixels inside of CircuitPython. So what you can see here, I've got a blend of colors going from red to green. So I'm specifying two endpoints, and the code here is solving the color gradation between them. So what I'll do, let me just do a little demo. I'm going to give it a different color. I've defined some colors here. So how about I'm going to go from blue to yellow, and I'll hit save. And what you'll see here is that it is going to calculate for 8 steps. That's how many pixels I'm telling it to do this between. The RGB values that fade it from red, green, blue color components of one color into another. Now, if I go ahead and run the full code, you'll see here really nice results from the full 64 pixels. We get much more gradual gradations here. So you can see I'm going from red to blue. Then the next one here is teal to amber, and then magenta to amber. Really like that amber. So you can do this with any colors you want, and the way this works is, in my code, I've imported Neopixel, I've set up a 64 Neopixel strip, and then I've defined a bunch of colors, and then I'm using these two key functions here. This function is I called create gradient, and it wants a start color, an end color, and the number of pixels. And what this does is it goes through and creates this variable called step R, step G, and step B, and these are the difference or delta between the color component that we're starting with and the color component that we're ending with. We then cast those to a list called gradient that has each of those tuples of RGB values for the 64 steps that we're going to be going through. Then I have another little function here called display gradient that just takes the number of LEDs I want to use, the start color, the end color, and how quickly I want to do it, and it feeds that into my function that creates the gradient. Then I've also got a function here for convenience called blank screen. So the main code here is just doing display gradient, 64, and then a couple of colors. I wait a little bit for that blank screen, and then do that all over again. And so this is one way that you can create a really nice color gradient between two colors inside of CircuitPython. And that is your CircuitPython Parsec. Yeah, let's look at those gradations for a moment here. Oh, you know, unfortunately my camera capture here is pretty good but not great for color rendition, so some of these are looking even better in real life. This one here has a little bit more pink at the top of it as it gradates down there. You can also see we get some funny little NeoPixel refresh rate stuff going on that the camera is picking up. That probably looks kind of cool if you go sideways with it, because it's always a sort of a scan line thing. And I also mentioned there are ways to do this in hue saturation value, HSV color model in the Rainbow I/O. But one of the cool things that you can get here in going through the RGB gradation is you can pass through black, which you can't really do with the hue saturation value because it's just running around the circle, the hue part of the circle, without adding extra components to it. So you can see here, if I do, let me adjust the code here, and I'll go from, how about orange to black. That'll just, oh, that's going to do it over 8 pixels. Let's do it over 64. That'll look nice. Running. There we go. So to be able to fade through the sort of center of the color circle is difficult in HSV, but kind of straightforward in the RGB color space, which is cool. And you can also imagine doing things with gamma correction. There's some cool stuff that Phil B has posted about gamma correction. Will give you a more perceptually linear rather than the exponential type of color transitions that we get with just straight up RGB. So lots of fun stuff you can do with color. This is just, by the way, a feather plugged into a 8x8 Neopixel matrix, and then I've got some nice little 3D printed. I think this was designed by Noah and Pedro for one of their projects. It's a nice little sort of color separation or light separation blocker grill, and then I put some of our LED plastic on top, the acrylic for diffusion. All right, so let's see what else is going on. Let me check out the anything else going on in the chat. No, looks like we're good. So projects, yeah. So I have I've demoed this guy, and I think we're just about done, just about wrapped up. But one thing I did want to maybe do is demo it with better sound. So I demonstrated some of this last night on Show and Tell, but it was really just that little speaker being picked up on my lapel mic. So what I'm going to do is actually try to use a guitar cabinet microphone, if I have a long enough cable on here. Let's see, there we go. And we'll see if I can get this to give you a nicer mix of the sound here. So let me just get a little bit set up here. So I'll show you, this is the mic I'm using. Right there. So that's designed to, this is a Sennheiser, I believe, and it's designed to be put in front of a guitar cabinet to mic the speaker on a guitar cabinet. And what I'll do, I'll actually hold that right about there. And I'm going to turn on a second fader on my mixer here, so that's going to bring this one in. Please tell me if there are any horrible feedbacks and screaming noises that are bugging you. There shouldn't be, but if anything like that happens, let me know. And what I'll do is I'll grab a battery to plug in the Computer Perfection synthesizer. And so if you're new joining us and you haven't seen this before, this is a 1979 toy that I gutted and replaced the innards with a Metro M7 that's running our CircuitPython Synth IO library to do some sort of drone synthesizer sounds. So this is going to hold notes when I press them. I'll just demonstrate that, as well as the ability to change the speed or frequency of a low frequency oscillator that's modulating sort of the timbre of the sound as we move between a couple of wave shapes. So let me start. So I'm going to turn up that sound, and I'll just wait a moment to hear if you can hear both me and the sound, or if I need to back off of either of those. So there's a slight delay in broadcast, so it might be a little faster on Twitch if you're watching there. But I'm going to wait a moment to hear what you can hear before I go demonstrating that any further. And let's see, we got a fader symbol. Okay, perfect. Thanks, Charles B. Appreciate that. Okay, so this green button here, I am repurposing to cycle between different speeds that I've set for that low frequency oscillator that shifts the waveform. So I'm going to tap it once to increase that speed. So you can hear this is a sine wave that is being used to adjust that mix of two wave shapes. Tap it again, faster. Okay. We could, of course, get bored of those sounds and add some new notes in. Can also hold down this red button to add 1 octave below the current pitch. So what I'll do is cut the sustain. So it'll fade back out. Now I'll hold that red button while I press a note, and we're going to get an octave below it as well as the original note. It's hard to do this way. Yeah, that'll work. So now we get a nice, rich, deep tone, as well as the octave above it. Means we got a lot of rich harmonics, a lot of rich frequencies to hear as we pan between them with that low frequency oscillator. And now I can long press that button to hold, to slow down that LFO. I'm going to get this real slow. I'm going to get it as slow as I've got it. So here we get this nice movement to the sound there. I also have a different set of waveforms that we can mix between. So if I move this switch here, this one has a mix of, I think it's a sawtooth wave on one side and a sine wave, no, sorry, and noise on the other, just pure white noise. I think that's the top speed that I've got there. And you don't have to sustain it. You can just play notes. I'm going to go back to the other waveform. And you could set those to be any notes. I have 2 sets of repeating 5-note intervals that I have on there. So that's it. You've probably seen a lot of this guy by now. Also, I'll show off a little more there. I've got my Neopixels doing their thing, which is when a note gets pressed, the 2 adjacent Neopixels light up with that little very high-density, thin Neopixel strip that I put in there. So I'm going to turn that microphone off there. We will use that again later, I think, because there was something else I wanted to demonstrate on a different synthesizer. But you can see, hopefully, why it's so exciting that we've gotten, mostly from Jeff Epler, thank you again, Jeff Epler, this ability to both create the LFOs and to assign them to other parameters, because without that we would be left trying to add knobs that we would have to manually move to do those kinds of adjustments or faders or whatever, which are nice and fun to have as well, but you only have so many arms. So pointing LFOs as modulation sources at other things is really nice. Yanisco, thank you. You said nice coloring on the lights. I think you're talking about these. I had no option other than red. Even if I set these Neopixels to be green or blue, red is the only thing that's coming through this really nice plastic filter on here. So that's the option. You get red. And I can't remember if it filters it out to the point. I think you don't really see it very well if you try doing like a pure green. I think it doesn't look like much of anything at all. In fact, that might be a fun thing to explore for a second. Why not? Let me plug this into my computer. I'll show you the code and we'll noodle with it a little bit. And we can look at what the lights do if we try setting those to other colors. So let me find a free USB port here. I have a lot of things plugged in. And I'm going to switch cameras to, how about that mode right there? Let me open up. Oh, please don't do that weird thing. All right, hold on. I'm gonna. Hopefully, I didn't just ruin. This is not the code editor I use normally. Oh, that's why. I've got 2 things plugged in. Okay. Shouldn't have ruined everything, but we'll find out. There we go. Yay, okay, it didn't overwrite it. So I'm going to take the exposure up a bit. Oops. That, okay, you can see that pretty well. And let me take the, color correct this a little bit. That looks pretty much like it does in real life. Okay. So in the code here, you can see, yeah, Andy Calloway, you can have any color you like so long as it's red. That's right. So in my LED setup, I'm doing this pixel map, which is what correlates the physical location of the Neopixels on this strip with the kind of positions on the computer perfection. You can see here I'm setting these to red right here. If I go ahead and set those to green and save this. Okay, those are full brightness, same brightness. You don't see much, and that's because of this red filter on here. Probably the same with blue. They might be a little blocked a little more. I think blue is on such an opposite end of the spectrum that barely any of that makes its way through that really strong red filtering of that plastic. There we go. So now it's back to being, whoops. There we go, back to red. So in fact, we might get a slight brightness increase if I go full white, but I bet it's not much. Yeah, it's not worth the extra milliamps there to do that. So kind of neat, kind of fun. The blue filter here, you can see that definitely cuts a lot of that red. As soon as that goes down, this translucent blue dome here, which by the way has survived since 1979 really nicely. I'm amazed that this isn't brittle. This is they've made this from a great plastic. It also didn't yellow that much. Probably wasn't in the sun because a lot of the times the bromine, there's a chemical inside of this plastic that's used to make it fire retardant that often would raise up to the surface and yellow these plastics on older gear from that era, particularly computers. But put some green LEDs under the buttons. Oh yeah. By the way, did you see this? Let me show you this. You will see. I'm going to get real close up. If I do change that color, you probably will see a little bit of light that's going to reflect off of the button base that doesn't go through the filter. So let me check my focus here for a second. So I'm going to do blue, and you'll probably see some blue light leaking around the edges there. Boop. There it is. You see that? That little blue light there is just bouncing off of there and not making its way through the filter, which is kind of neat. All right. So let's see. I think I've gone over most other code stuff on this. Maybe I'll go through the guide when it's actually published next week and run through some of it. But otherwise, it is all this good SynthIO stuff. So yay. Some stuff that I'll show about filtering next, which is a feature that's happening right now that Jepler and Mark Gambler, maybe some others, are working on, that will give us the ability to filter certain frequencies from the sounds that we're hearing, from the sounds that we're playing. So I think this would be a good time to talk about that. I've probably talked about filtering before. I've shown it a lot. You'll see, you've probably noticed that filters are one of the favorite things to show off in synthesizer demonstrations and even just in playing music, because they are very noticeable. You can correlate a knob twiddle with a big change in the sound based on the character of the sound that you're hearing. Let me set this over here. But I wanted to just give a little demo here that I think will be helpful as we enter into doing some filter stuff inside of Synth.io. But I'm going to demonstrate this with an existing synthesizer I have. I've shown this before. Oops, not over there. Back over here. I've shown this synth before because it sounds great, has a bazillion features that I like, and has some good visualization of what's going on. So this is this synth that's called the Micro Freak from Arturia. I'm going to go ahead and put it in focus first of all, and I might focus in a little closer here on that little OLED once it's fired up. There we go. This synthesizer, by the way, I don't have it updated, but it is the little synth that keeps on giving. They've just updated the firmware to a 5.0 release that adds sampling and granular synthesis and some other features. So it's, it's software. It's a digital synth. I think the filters might be analog, but most of this is digital, so it can get major updates in software, and they've been updating it over the years, which is great. So I'm going to go ahead and power this off of a USB battery. Hopefully that one lasts, because it's a good way to avoid ground loops. And again, I'm going to turn on my cabinet mic so that you can hear a mix of my voice and this in there. Okay, so tell me how that mix works. I'll lower it for me so I can still hear myself. So again, I'll wait a couple seconds here for the stream to catch up, and let me know if you can actually hear me speaking as well as that. Charles B, not bad. Okay, would you want it changed in one direction or another more? I'm gonna move the mic a little closer. There we go. So that mic should not be picking up my voice too much. It's pretty directional. And any other feedback? Let me know. Here comes the feedback. I'm watching the Discord there. A little more on the synth. Okay, great. I guess I could watch my levels there. There we go. We're about even now. Okay, so I'll leave it at that. Let me know if that's not adequate. So what I'm going to do here is I'm going to go to a basic synth patch here. Okay, so what you're hearing is a little bit buzzy, which is good. It's got some harmonics in it that are going to be filterable. So if you've got a nice buzzy sound, thanks Tyeth, that's working well as is, then what a filter can do is it can cut off upper frequencies if it's a low-pass filter, it can cut off lower frequencies if it's a high-pass filter, or it can cut off everything to the right and the left of a certain range if it's a band-pass filter. And there are other types, notch filters and things, but those are the three that are on here. And you can see right here, there's this thing that says type, LPF, low-pass filter, BPF, band-pass filter, HPF, high-pass filter. So we'll go with a low-pass filter right now. And if I just twiddle one of these knobs, you'll see the cutoff frequency is indicated, as well as a nice little curve there. So that's telling me that we're going to cut off frequencies above 26.9 kilohertz. And as I lower this, my cutoff is happening lower and lower to where this becomes a really bassy, muted kind of sound. Okay. Having it fully open like that means I'm really not cutting off any frequencies that are audible. If I do the high-pass filter, same thing. If I crank it all the way to the bottom, it's cutting off anything below 16 hertz, which I can't hear. Probably a whale can. But as I raise this, I'm going to cut off frequencies that are increasing, like from the bottom up, so I'll only hear the upper stuff. Okay, so that's what those do. Band pass is right in the sort of middle. It picks a range that it runs with. And I don't find myself using those as often. So let's go back to the low-pass filter. And the second feature that we really enjoy playing around with filters is a parameter called resonance. And what this does is it actually gives a little boost to the frequencies right at that cutoff point, right at that little knee where you see that shape drop off. You can peak that up. So watch as I raise the resonance. And then I can slide that around. And I think that graph does a good job of showing you the idea, which is that we're actually boosting frequencies right at that edge of where we start cutting them off. So we really emphasize that one part of the audible spectrum there. Same with the high-pass filter. Okay. The last thing I'll show about this is just, and I've shown this sort of thing before, but what I'm going to do is I'm going to move, whoops, not that. I'm going to move the little camera of me out of the way here and update that. What I'm going to do is, remember I've talked about this ability to take our, in Synth.io, low-frequency oscillator objects and essentially modulate other things with them. So if I want to automate, let me just hold a note or a chord. Right, so if I want that to be constantly moving in and out at this regular pace, then I can take a low-frequency oscillator and modulate that cutoff frequency. So it's just as if someone's sitting there doing this or you've hooked up a motor, but we can do that in software. So to do that, I'll go and I'm going to take this modulation matrix and I'm going to just match up the columns and rows of the LFO and the cutoff. And then I'll give it a attenuation, a certain percentage. I think this goes up to 100. Yeah, so I could say 50-ish%, so it won't totally cut off, but we'll hear now. Right, so it's like I'm moving that cutoff knob real fast. I can slow this LFO down with this rate knob. And I can also where is it? I want to be able to freely change that. Where is the thing I'm looking for? It's not in shape. Now I can't remember how to tell it not to. It's doing it in like time divisions of a beats per second right now, and I can't remember how to tell it to stop doing it that way. Do I click you? Yeah, okay. So now I can just pick a frequency, which is kind of more like how it works in Synth.io. And so that type of change in the speed or frequency of that LFO is what I'm doing on the Computer Perfection project with that one green button that I was tapping, speeding it up, slowing it down. And we can make it a little more subtle. By changing essentially the strength of this low-frequency oscillator on the modulation target. So the target here is this cutoff knob. Now it's as if I'm wiggling it, but not its full range from 0 to 100. I'm just wiggling it in what, 0 to 20, 0 to 6 here. Right, so it gives us a little more movement. It's a little more useful musically than a full sort of crazy effect often. Not always, some musical benefit from that. So yeah, I think that covers the upcoming filter stuff. There's also the math blocks that are being used to add and multiply waves together. Maybe I'll demonstrate something like that next week, but that's all I wanted to cover on that. So let me know if you have any thoughts or questions in the chat. I like Gary T's comment when I was doing the high-pitched stuff, said, and all the dogs go wild. Also, Todd has posted a pretty cool synthesizer that's designed for kids. There's another one, the Blip Blocks, I think is what it's called, that looks exactly like a Fisher-Price toy. Super cool. In fact, look at this thing. I was just talking to someone about this online. Blip Blocks. Playtime Engineering Blip Blocks. They make 3 of them. This one's $189. I think they were doing a sale or a special. You'll find them sometimes on a little bit of a discount, but full-blown synthesizer that does all these things that I'm showing and talking about here, except with an interface that's made to explore. So you can see they didn't put any text on it to tell you what it's doing, but if you look at the manual, it'll show you, oh, this thing's an LFO, and you can direct it into one of these multiple targets. Really cool gizmo there, and they have a couple different ones, and they have some new version coming out that's like a sampler in the sequencer, but that one looks super cool. I keep hoping I'm going to find one of those at a Goodwill or something, at a thrift store for $5 because they think it's just a Fisher-Price toy and not a really cool synthesizer. But anyway, that's the Blip Blocks. So let's see, that takes us up to... okay, so I got some questions over in Discord. Okay, you're on. Says, what version of CircuitPython includes the new filters? The beta 8.0.2, is that what it is? Let me check. I think that's the one I've been using. I was grabbing stuff from S3, but now I'm able to go right to the beta is the one I grabbed it from. So if we go to circuitpython.org, pick your board. Let me make this a little bigger so that go to downloads up here. This is the Metro M7 that I'm running it on. It'll run on other boards though. I think the RP2040s, most of those will support it. So 8.2.0 beta 0 is the one I've been using that has the... Oh, sorry, you asked about filters. No. I don't think filters are in that one. I think filters are in a S3. If Toddbot, yeah, it looks like you're answering, or if Jepler's around. I haven't played with the filters yet, so. It is not merged, it's in a draft PR, yeah. So that's 8048 is where the filters are. Also, by the way, if you're curious about the development that's going on with these, you can actually head to our Discord, and in the CircuitPython dev topic or channel, there's a SynthIO feedback thread in there, and you'll find a bunch of discussion going on in there about our development. So, whoops, where'd I go? Oh, I'm all over the place. There, that's where I went. Sorry, I got distracted by, I just started reading my texts there. Nothing scandalous. So let's jump back up to live broadcast chat. Here we go. So yeah, Steve, you can check out filters there and the development of that. I think Jepler has posted some demos of filter stuff that he's been experimenting with. And I think if you check out last night's show and tell, there was a demo by Gambler of some synthesized drum sounds, and I suspect he was using filters to create those synthesized drum sounds. So he's got a gist up for that he posted in the chat if you just scroll up a little bit earlier. All right, so let's see, what are we up to now? Let's take a hard right turn into PlayStation controller stuff. So let me show this and talk about it. So this is a pretty unique PlayStation controller here that is from, I think Takara makes it. They're a consumer products, electronics, games manufacturer in Japan. They never released this in the US, but this was for a PlayStation 1 Game of Life game. So I don't know if it was licensed or just similar, but for anyone who grew up playing the Game of Life, you recognize that spinner in the middle there, which is how you pick you randomize your life events, and I think how far you move on the board and things like that. So they made a controller that you can see has pretty much the standard set of PlayStation 1 controller buttons. So there's a D-pad, there's start, select. The two shoulder buttons are represented up at the top there, L1, L2, R1, R2. And then the triangle, circle, square, and X at the bottom right there. So what this spinner does, this is really something you'll see a lot in the kind of cool oddball controllers that have often been created, is that they're piggybacking on an existing controller protocol, and so they got to find a way in their software to deal with only expected events from the existing controllers, but add on their neat, weird physical thingy. So this was PSX or PlayStation 1, where there were no analog anything. So the analog sticks didn't come until I think the DualShock 2 on the PlayStation 2. Maybe there was a PlayStation 1 that had that simulated, I don't know. But for this type of controller, what they do is they piggyback on one of the other buttons. And so much like a turbo button, if you look at any controller that has a turbo button on it, it's just spamming some existing key for you without you having to press it. This thing, turns out, spams that circle button right there when that gets spun. So every time you spin that, it's just pressing the circle button. So the way that game must have worked is that it expected when it was time for you to spin for your turn, it probably, I'm guessing, ignored the circle button by only listening to presses that start with an incredibly high rate. That's my guess. But who knows, maybe you could cheat and go 5 spaces by pressing the circle 5 times real fast. I kind of doubt it. So the way this thing works, let me jump over here, is by including an optical encoder wheel and sensor. So right under there, you can see there's a little probably infrared transmitter and infrared receiver. A little package here. I don't know if you can see that too well, but there's some little shiny LEDs in there. So this is a kind of like a brake beam sensor. It's going to reflect light off of this disc, and then when black passes, it's going to register that as a press. And so as that spins by really fast, it's counting those and sending along the appropriate button presses of the circle button to the game. One of the neat things about this that I noticed is when you finish a spin, it actually does that little bounce back and forth thing. Now, since this does not have uniquely spaced slits on it or a second encoder, it can't tell direction. So there are rotary encoders that can, optical rotary encoders that can, and this one cannot. So it doesn't matter which way you spin it. But this will register as another couple of extra hits at the end there. So I don't know if they were using that to any effect in parts of the game, but I'm guessing that moving around the board, it's not a color sensor. It doesn't know what color is under there, but it's just a set of steps. So wherever you were, that might be interpreted as 12 steps forward on the board. So Phil Terone found this thing. He has a knack for finding unusual controllers and sending them to me and saying, hey, go on eBay and get one of these things and see what we can do with it. So first of all, I really dig this as a PlayStation controller. It's kind of, if you ignore everything up here, it's kind of a nice NES-shaped controller with the exception of these things up here and the extra buttons. But these two, and the D-pad are kind of an NES controller. It had one of these Player 1, Player 2 switches on the bottom that were used in some games that were two-player that could be played with two regular controllers, or if you have a special controller, in order to make it fair, you can pass it to Player 2 and flip that switch, is how often that's set up, this A and B that it lists at the bottom there. I think that's probably what that's for. But what my first thought is okay, this has the standard PlayStation, I think it's a 9-pin port here. And what you do is you go and you buy yourself, for like $3, one of these PlayStation extender cables, which you can then cut in half. And now you have a receiving side that you can plug into. So in this case, we have the pins on the controller, and we can plug into this half here. If you cut that in half, you end up with, I think they just have 8 wires here. Even though there are 9 pins, there I think is one just listed as unused if you look up the pinouts on them. So I took these, tinned them, and made myself a little breakout, which you can see here. It's a little sort of temporary breakout that just breaks the wires out to header pins, and then I can run jumpers over into something else. So Googling this, what I found was a PlayStation, PSX, and PS2 controller library that had been written for Arduino. There's a couple of them. And one of those had been ported to CircuitPython and runs on the Pico, so I figured I'd give that one a try. So what I do here is just plug in the roulette wheel, the Game of Life controller, on one end, and then I can plug into USB on this end on the computer, and we can see what kind of button presses it's going to register. So let me go ahead and unplug the little synthesizer and put that away. And let me drop to this camera right here. It's running up in the corner. And I will again adjust some camera settings if you don't mind. Boop. Boop. Oh, that saturation, I dropped it way down, didn't I? And it's very warm. It looks more like real life. Okay, let me focus that again. Okay, I'll leave it like that. So I'm gonna, again, head on over here and plug that USB in. And I will open up that code that's running on there. There we go. And I'm going to toggle a terminal here. Okay, so now I'll see some serial output. So I'm going to leave the cursor down here for a second so we just see some buttons getting read. So what I have is a print statement that'll show me the button within one of the two 8-bit bit masks. Oh, I've got a double me on there. Hold on, let me. There, get that out of there. And in the case of, I think it's basically one half of the controller and the other half of the controller, it sends these, I believe, bit masks of which buttons are pressed, all as one kind of quick report, so it's not slowed down and sending one report per button. And I'm also printing out time monotonic, just so if I'm holding something, I can see it kind of increasing. That's just a thing I like to do to be able to tell when I'm holding a button down, because sometimes you can see on this side I'm not. Now I can't tell if it's registering presses or not. So a quick easy way to change that if you're pressing the same thing over and over again is just to print time monotonic along with the button press. So the code for that you can see right here. And I'll increase that size a little bit, make it a little easier to see. So that's just happening on some of these. So what happens when I spin the controller? You can see I'm getting, whoa, let me get my cursor out of there. I'm getting a bunch of these presses of button 5, which is the same as the circle button over here. So those are sending all on that side. This is sending on this side. And then what this code does is it is converting those into USB HID keyboard presses. So this, let me show the library for a second. That's not it. Okay, so this is the one that I found that I'm using right now. It seems to be a good start, but it is very slow at sending the keyboard presses, and I'm not sure what's throttling that. It seems like it's kind of choking. So I'm gonna look at some of those Arduino libraries and some other code and sources of inspiration for getting this to work well. But this was a great way to start because it gives you a nice fritzing diagram there of how to plug in the controller wiring into your Pico. So it's reading on a bunch of GPIO pins, and then it just is getting power and ground. I think it wants 5 volt. I think anywhere from 5 to 7.2 or something like that is what the PlayStation controller wants. So anyway, if that's interesting to you, this is non-Dan here, Pi PS2. And there's a version of this for the PS2 controller with analog and rumble, and then there's the version I'm using which does not have those features. So what you'll see if I go ahead and click up in the code editor here, I'm just going to put a comment line. So if I press O, triangle, X, square, those happen to be in code correlated to send the O, I, K, and L. If I press the D-pad, W, A, S, D, or W, A, S, D, there we go. So all of the buttons on here just press keyboard commands, which is a great way to use this sort of thing if you just want to plug it into a computer and then map your keys, let's say in an emulator or something like that, map your key presses to, or your button presses on the controller to key presses. Especially simple when you're not doing stuff like an analog. The issue that I'm having here is when I spin the spinner, it's going to press the O button, but it doesn't really press it as many times as it should. So I think something is going on with the timing and the flooding of the USB HID keyboard commands, so it's just given up. It'll send 1 or 2, but it's choking quickly. So I expect to see pretty much the same number of those or close to it as the serial read, and that could be, I may have a unrealistic expectation there of how quickly USB HID can press stuff. But you'll see if I just press, if I spam some of these keys, it can handle that kind of a rate. I think the controller in here will not respond to the sensor, the rotary encoder, until it gets above a certain rate. So you can see if I just click this, it's not, oh, let me add some other stuff. So that's me clicking it 3 times. Those don't seem to show up. So I've got to give it a bit of a spin for those to show up. So that's the issues that I'm dealing with there. The question is what to do with it. So Phil and the more we're talking about, it might be fun to do one of the clicking types of games, tapping types of games. You see these on the iPhone a lot, but they probably exist also on the PC. I haven't looked. I'll probably find some on itch.io or somewhere like that. But games where you're just spamming some button a bunch, it might be fun to be able to just spin this. Like I said, it's not directional, so we can't use this to pretend we have a rotary encoder and do a game of Pong or Brickout or something like that. Arkanoid doesn't know what direction that you're spinning it in, so it's really just a button presser with some panache. So let me know if you have any thoughts on ways to use this, as well as ideas on what might be broken with it at the moment in the code there, if you want to take a look at that. So that is what I've got with the PlayStation controller. And that's pretty much it. That's what I got for you for today. I will mention again, we have a coupon code for you that'll get you 10% off in the store. So on the way out, type in roulette, and that will get you a nice big savings as you head out. And that is, like I say, good on any stuff you can buy, any of the new products. It won't work on gift certificates, software, or subscriptions, so just get some real stuff. Anyway, that is it for me for today. Thank you all for stopping by. Dave Odessa, maybe I'll do 1080p next week. Maybe I'll be brave. We'll see. See how that goes. I'm just so happy that I'm mostly, knock wood, not getting dropped frames and things at the moment. All right, that is it. Thank you, everybody, for stopping by. For Adafruit Industries, I'm John Park, and this has been John Park's Workshop. Please tune in tomorrow for Deep Dive with Foamy Guy. Then come on back next week for another product pick of the week, 3D Hangouts, Show and Tell, Ask an Engineer, and more. Thanks, everyone. Bye-bye.
You